Let's say we are starting with a function x squared, and if we wanted to take its derivative, we could use the power rule, where we could find f prime of x would be equal to 2x, bringing the power down, and then subtracting 1 from the previous power. Now, if we wanted to do the inverse of this process, we would use a technique. We would be doing anti-differentiation. In the same way that addition and subtraction are inverse properties of one another, and multiplication and division are inverse properties of one another, differentiation and anti-differentiation are inverse properties of one another. So that would mean that the antiderivative of 2x could be x squared. But because it could be x squared or x squared plus 1 or x squared plus 2 or x squared plus 3, and we're not sure which one of those is necessarily what, we would say things like it's going to be x squared plus c, because we don't know exactly what the constant would have been. The process of anti-differentiation is also called integration. If we're going to integrate, the symbol that we would use for such things, roll up, well, the x. And this means that we're going to integrate the function x squared with respect to the variable x. And so the dx is telling us which variable are we focusing on when we're integrating. And we know from the power rule that this thing would increase 1 because we're reversing the process of the x cubed. And we also know from the power rule that there must have been a constant here, 1/3. Because when I take the derivative of 1/3 x cubed, I would bring the power down, and 3 times 1/3 is 1. So this is a constant there. Decrease the power by 1, become plus c. And last thing is sometimes it's difficult to figure out what this constant needs to be. But I do know that when I take the derivative, I would have multiplied by 3. And that 3 would have been multiplied by something to get 1. When I solve for that something, I get 1/3. So using this process is useful if I'm thinking about the power rule and what must have happened if I took the derivative of this. Here we're doing a technique called definite integration. And one way to think about why it's indefinite is we'll never be able to arrive at exactly what this c is. I'm not sure. We can't narrow it down to which of the infinite number of possibilities have a derivative of x squared. In the same way that we couldn't narrow down which of these of the infinite number of possibilities have a derivative of 2x. Say it's plus c until we get some more information.